A very good morning, everyone, and welcome to my talk, Livewire Beyond the Basics. So as Aaron mentioned, see if the clicker works. There we go. My name is Philo. I'm from Amsterdam. I live there with my dog Cooper, and yes, I'm aware of the saying that dogs often tend to look like their owner. So I work on a bunch of different products to make a living, and a few years ago, I got into Livewire. And one of the first products that I went full on Livewire was AnyStack. And if you're unfamiliar with Livewire, Livewire is a package for Laravel that allows you to build very powerful dynamic UIs. And the great thing about this is that, let's say you want to do some string manipulation, you don't have to go to npm to look up a string manipulation package. You can simply use the string helper that is available within Livewire, or Laravel, or any framework feature for that matter. So, AnyStack is one of the platforms that I've built with Livewire. It's a platform where you can connect your GitHub repo and start making a living selling code. During this process, I also made various components, and that eventually led to the launch of Wire Elements, which is a component library for Livewire. Just a few components. They're very opinionated, but they have over 2 million downloads, which is pretty crazy. And last year, I also launched Wirebox, which is a free-to-use, cloud-based Livewire editor, where you can tinker with Livewire online, share it with your colleagues, ask AI for some feedback. So yeah, let's get into the talk. Today, I'm going to talk about performance. I'm going to talk about security and learning from the source. So let's dive in. So, when you get started with Livewire, you might do some research and think, I want to know how performant Livewire is. And you'll probably end up on some Reddit topic where someone would say, Livewire's performance is not that great. It only works for very small components. And I personally disagree. I think this is more about not knowing how to use a specific tool. If I will put you in a Lamborghini and you have no idea how to shift gears or how to operate the car, you are going to complain that this car does not work. So, payload and response size. Let's imagine we have the following component. We have a public property where we can track the count. We have an increment method that we can use to increment the count. And we render this component using one of these different flavors. So I've been asking around, like, do you know what this actually does? And people say, yeah, it renders my component. And while that's true, there's also some extra magic happening behind the scenes. Because if we take a look at the root element of our components, we have something called wire snapshot that has been added, and this is not something that we did. And if we take a look at the wire snapshot, we can see that this contains a JSON object. And this consists out of a data object that contains the public properties of our component. We have a memo. This is used internally by Livewire to track the components on the page, like the name, the ID, whether it's having child components. And finally, there's a checksum to ensure that this data is not tampered with. So this data is also used by the client side of Livewire. Now, if you start with Livewire, you might not even be aware of it, but there's actually a ton of JavaScript that does all the heavy lifting for you. And this client library is actually very isolated. And in version 2 of Livewire, I tried to make Livewire components embeddable. Was not really able to achieve it only by using iframes, but in Livewire v3, I was able to create a little package called Wire Extender, and I thought it was pretty cool to show you that it is now possible to embed components anywhere. You can just have the server render them. This is basically all the code you need, and you can create a static HTML file and simply render your Livewire component. So you can even put it in a React app or a Vue app, which is pretty neat. So if we take a look at this counter, whenever we click the increment button, we will start sending off requests to the update endpoint. Now, if we take a look at the request payload, we can see that we're sending along this snapshot where the count is set to 0, and in this case, we are also calling the increment method, stating that we want to increase the count. Now, if we take a look at the response, we can see that we get a new snapshot back, where in this case, the count has increased to 1. And this is because the snapshot data is stored on the client side. Any public data or public property that you define on the Livewire component will be stored on the client side. Finally, we get the newly HTML back. And if we take a look at an example, Sometimes we see people complain that the UI starts to get a little bit slow. So this is an exaggeration, but here we have a table with 600 users. And when we attempt to assign a country to a given user, we can see that the first one works, but when I start clicking the additional drop-down menus, we get no response at all. And it takes like 5-6 seconds before the UI to catch up, and there we go. So that's not a really nice experience. And the same goes for assigning a different role to a user. The UI starts to freeze up. So why is this? Now, if you take a look at the user overview, it's very simple. We're just looping through these users. We have a wire change directive where we assign a country to a user, and we have a simple wire click handler where we assign a new role. Now, if we take a look at the component, this is something I often tend to see, that people start to assign everything as public properties. So in this case, we're getting users, countries, roles, and it could be an enum, it could be a external API that we're fetching. And this is not the best way to do it, because again, any public properties are stored on the client side, and we are not really interacting with this data. So if we take a look at the numbers here, we can see that this is not that great. The payload that we're sending across the wire on every request is like a little over 50 kilobytes. The response size is 1.6 megabyte. And finally, the response time is a little over 900 milliseconds. Now, the UI starts to freeze up because Livewire does something called morphing. It compares the existing HTML to the new HTML and only updates those things that have changed. Now, the front-end client is currently crunching 1.6 megabyte of HTML, and that's quite an intense task, and that is why the UI starts to freeze up. If we take a look at the request payload, we can see that we're sending along all these 600 users, we're sending along all countries, and all these different roles. And this does not make sense. So instead, we can get rid of all those public properties, we can get rid of the mount method, and use computer properties, for example. Computer properties can be triggered by adding a computer property or computed attribute to your method. So in this case, we have users, countries, roles. Again, it could be an API call, it could be an Laracon call, and Livewire will treat these as sort of an in-cache array. If we would call users 10 times within a single request, the query will only be performed once. And when we then look back at the numbers, we can see that we improved the payload quite significantly with 99%. The response size has increased or decreased a little bit as well, and we got an improvement of about 3%, but the response time has gone a little bit up. So let's see how we can fix this. So if we take a look at the method that is responsible for assigning a country, again, this is just for demo purposes. You should do some authorization to check whether someone is authorized to do this. But in this case, we are not bothered by any UI updates. We just want this code to be executed, and there's no UI that is related to this method being executed and that some change has to occur. So what we can do here is use a renderless attribute. And in Livewire 2, this was called skip render. And this tells Livewire, just execute the following code, but don't be bothered to send a response back with the HTML. So it will skip the entire morphing process. So if we now look at the numbers again, we can see that the response size has gone down as well. We had a 99.9% improvement, and the response time has improved significantly as well with 94%. So that's pretty nice. Now, if we take a look at the table again and we try to assign a country, we can now see that there is no more UI lag. We can instantly go on and select additional countries. For the role assignment, however, we still get this lag. Whenever we try to assign, in this case, a visitor role, you can see that the UI does not respond. It takes a few seconds for everything to be processed, for it eventually to update those check marks. So let's see how we can prove that. So if we take a look at the table, we can see that we're simply looping through all of our users and using the click handler to assign a role. Now, this is a very chunky table with 600 users, and one way we can do this is by using child components. So Livewire doesn't have partial renders at this time, but you can achieve the same result by using child components. So if we replace this entire for each loop with a new component, for example, a role assigner, we simply pass along the user to this given component. And if we take a look at the component itself, we simply accept that given user. We have the same method to assign the role, and we have our computer property. And the HTML just got a little update instead that we are no longer having to need to reference the user because the component is already user aware. And if we then give this another try, we can see that the country selector still works as expected. But in this case, when we start assign a different role, we should see the same effect where we get an instant change and no more lag. So that's perfect. Let's look at the numbers. Again, a 99.9% improvement and a 95% improvement on the response time. So now we have a very snappy UI. So whenever you start working with very data-rich tables, dashboards, etc., try and consider whether it's an optimal choice to start using child components. You make your code more organized, more structured, and Livewire is very smart that it knows exactly which component has triggered a certain action and only re-rendered that given component and leaving the rest of the UI alone so you don't get any UI lag, as I've shown just now. Next up is latency. Because Livewire is server-side rendered, we want, of course, to make sure that the latency is as low as possible, because if we have a high latency, it's going to take a little bit longer for a component to render. So this is going to apply to a generic Laravel application as well. This is something that I experienced with one of my projects, so I thought it would be interesting to share how I solved it in this case. So I had this little app running in a server in the EU, in Germany to be exact, and it's an app that has an embeddable form where users can add entries, and there is a back office where users can see all the entries, manage the data, etc. And this app was growing over time, and eventually I got some messages like, hey, we love your app, but this embeddable form of yours takes like 2.5 seconds to show up. And I said, seems fine on my end. I said, where are you from? And it turns out I was getting a lot more users from the US. And they were waiting 2.5 seconds for this form to render. So my initial thought was, okay, Livewire server-side rendered. That means I'm just going to add more compute power on the edge, so that's closer to my user. So I added 2 additional servers in the US. I added a Cloudflare geo-based load balancer, and it improved a little. It went down to 1.8 seconds, but that's still not that great. Next, I enabled Cloudflare Argo, which is a product that minimizes the amount of network hops a user has to take, which is pretty crazy that just with a toggle, it improved like 20%. But still, 1.2 seconds, it can be better. So this embeddable form was performing 2 eloquent queries, and I thought, let's see what happens if I cache those. And it turns out that was the most significant improvement that I could make. It went down to 200 to 300 milliseconds, and finally I added Laravel Octane, and that brought the entire response time to below 100 milliseconds. So that's perfect. We get a very snappy UI and instant feedback for users. So this was just the embeddable form. There was also this back office, and I thought, well, while I'm at it, let's see how that is performing. And it turns out that I was experiencing the same as our friends at Vercel, that rendering something on the edge does not really work well if your data lives somewhere else. So in my case, this data was running on AWS RDS in a server in Europe, so the back office was still pretty slow. In some cases, it was even 3 to 8 seconds, so that's pretty bad. So in my case, this was a pretty easy solution. I simply clicked the create read replica twice, got 2 new servers, and voila, the response time improved quite a lot. So now you might argue, but is this the best solution? Well, for this specific project, this was a very useful and obvious choice for me to make, because instead of having 1 big server, I now have 3 little smaller servers. I have automatic failover support, and AWS supports like, or gives you like a 60–70% discount on a RDS instance if you pay a year upfront or 3 years. So you can get a pretty good deal and have a very solid infrastructure. So now you might think, okay, that's great, but how would I implement something like this within Laravel? So as I mentioned, I had these 3 different instances, and each of those instances have a unique host name that includes the region. And I found this trick on Philo in an article written by Chris, and it turns out that it was a pretty cool trick how you can achieve that. In this case, John, who is visiting from California, is going to connect to the correct database instance. So Cloudflare is taking care of making sure that John is connected to the correct instance that is nearest to him. And in this case, it is possible to use a little snippet in the app service provider to change the read config on the fly. So we're simply doing a match statement. So this code is going to be executed on the West instance. The match statement is going to see, okay, in this case, I have to read the repool config from the database file and set the config on the fly. Now if we take a look at the database config itself, we have the primary write server, and we have a few separate database pools where our read replicas are found, so just the IP addresses, and this is all it took to have Laravel connect to the correct instance based on the server that the user was connected to. So it's pretty neat that this was just such a small change that was required in order to get this to work. Now there were still a few challenges, and that is regarding the sticky option. And let me show you what that is all about. So this is how a regular request works when you use a read and write structure within Laravel. So we have a request coming into our app. Our app is going to perform a select query that goes to our read server. We have an insert query that is going to our write server, and another select query goes to read server, etc. And finally returns a response to the user. And a new request occurs, and again, same behavior. Now, when you enable the sticky feature within Laravel, this behavior changes a little bit. Again, request from the client comes in, goes to our app. Our app is going to perform the select query from our read server. The insert query is going to our write server. But now the consecutive read query is going to stick to our primary server. And this is going to ensure that, in this case, our query is always going to return the most up-to-date data. Because if you start using a read and write replica, or sorry, a write server and a read replica, you can have something that is called replication lag. So the read server is trying to keep in sync with our primary write server, but it could take a few milliseconds to up to a few seconds for the server to be fully in sync. And this poses an issue, which I'll get into next, because if you can see this, on the next request, it falls back again to the read server. And this poses a problem because let's imagine that we create a post. When the post is created, we fetch the post from the database, we get the post ID, and now the user is going to end up with a 404 not found because the read server might be lagging behind a little bit. Again, it could be a couple milliseconds, it could be a couple of seconds, but that is not a very good experience for our user. So I went looking, is there a solution for this? And luckily, someone in the community already solved this. And this is a really neat package called Laravel Cached Database Stickiness. And it basically allows you to have the stickiness cached across multiple requests. So this is pretty cool because now, again, we get the same order. We perform a select query, goes to our read server, insert goes to the write server. Our next select query goes to the write server again. And when we do a new request, that select query is also going to stick to that write server. And you can define within the config the, sorry about that. Within the config of this package, you can define how many seconds it should stick to that write server. So it could be 1 second, 2 seconds, it just depends on your database configuration. And this will ensure that the user always gets the most up-to-date data and no 404s. Now, because we're connecting to the write server, there is one downside, because this is still going to do that round trip to, in this case, this server in Europe. So we still get a little bit of a slower response. But in this case, we are not showing a 404. But in those cases where we might have to work with a little bit slower connection, we can look at something called optimistic UIs. And this is actually something Caleb showed back in April, which I thought was pretty cool. So let's imagine that we have the following to-do list. And we have to make that round trip to that server in the EU because we're performing a write query or insert query. So this is going to take some more time. So when I check one of these items off, you can see a loading indicator in the top right. And once the request is finished, the item disappears from the to-do list. But in this case, we can be pretty optimistic that whenever we check an item off, we can hide it instantly instead of waiting for the request to finish. And that is what optimistic UIs are all about. So again, this is something Caleb showed back in April, which is pretty cool. You can see we have a wire loading directive, and this will show the spinner whenever a request is ongoing. But there is also an inverse of this. So we can simply add wire loading and add the remove modifier. And this is going to do the inverse. So whenever a request is loading, it is going to remove this given element from the page. Now, in this case, it is going to remove all those to-do items because we've only used the directive to instruct this given element to be hidden, but we only want this specific to-do to be hidden whenever we perform this action. So we can use wire target for this. And wire target basically has to match the same signature of the action that we're performing. So here you can see that wire target matches our wire click. In this case, whenever a remove for a given to-do is triggered, it will only hide this to-do. So now if we give this a new try, you can see when we check off the item, it disappears instantly, even though the request is still pending, because we're optimistic that the request will succeed and that the new UI or the new HTML that's returned by Livewire is not going to contain that specific to-do item. And let's say something did went wrong, it will simply pop up again. Now there's a lot more to it, to optimistic UI, so our friends at Titan wrote a really cool blog post about some tips and tricks regarding optimistic UIs when using Livewire and Alpine, so definitely go check that out. Some really interesting things there. And finally, I want to talk, or not finally, this is one more thing. I want to talk about security. So this is still a sort of basic thing, but I see a lot of people get off guard by this. So who here uses model unguard whenever they start a new Laravel project? Okay, there are a few. So for those who are unfamiliar with model unguard, Laravel protects you by default by doing something like this. Let's imagine that we have this is a potential attack vector if you don't use model guard, because a user could add a password property to that request, and in this case, the password column in your database will be updated. And when you use model guard, this is going to protect against this unless the password field has been defined as a fillable property. Now, within Livewire, public properties are open by design. As I mentioned, they are stored on the client side, and this is something you should be very aware of. Because let's imagine we have a component that shows the user balance of a user, and we render it on the page like this. Your initial thought might be, well, this is server-side rendered, so a user is not able to tinker with it or change something. And that is not the case, because again, public properties are stored on the client side, which also means that we can use the client library of Livewire to adjust this value. So let's imagine that we are currently seeing our current balance. We can use the client of Livewire to simply get the first component on the page, use the set function, and change the user ID to user2, and now we have the balance of user2 or user3. Again, this is because Livewire is open by design. These public properties are something you should be aware of. And of course, there's something to protect you from this as well, and that is by using the locked attribute. So if you add this given attribute to a public property, this will ensure that this value cannot be tinkered with or changed using the client library. So if we now give this another try, you will see that we get an exception because this is a locked property. As you can see, we get a cannot update locked property. A few weeks ago, I also launched this new package called Livewire Strict, which basically does the same as model guard. So this will ensure that all your public properties within Livewire are locked by default, and you can use an unlocked attribute to unlock a given public property. So if you ever want to make sure that you never run into a mistake where you by accident have left a sensitive public property unlocked, in this case you can use this package to ensure that everything is locked by default. Finally, I want to end with learning from the source. It can be a lot of fun to simply browse the code of the Livewire codebase, and I'm not saying you have to go through each and every line, but the neat thing about Livewire is that all the features are located in a feature directory. So if you want to learn more about how lazy loading works within Livewire, you can simply go into the features directory and open the supports lazy loading directory. And here you can find the actual implementation plus the test all in one single folder. So it's very easy to learn a specific feature within Livewire. The same goes for the client library. There's a features directory as well, and you can simply open up the lazyloading.js file to learn about more on how this is implemented on the client side. So when I was building this Wire Strict package, I did the same process. I needed to find a way, okay, how can I hook into Livewire components without having to ask users to add a trait? Turns out Livewire has a really cool feature. I don't think it's in the docs yet, but you can add your own component hook. So we just resolved the Livewire instance from the IOC container, and we call the component hook, and we add, in this case, our own class. And we can define an update method in this case. And now for all Livewire components, this update method is going to be triggered. So here I added my implementation to add support for locking properties by default. So I thought this was a really cool thing if you want to add more logic to all your Livewire components without having to use trade. The component hook is a very neat system. And with that, I want to thank you all for listening. Enjoy the rest of the conference. If you have any questions, reach out on Twitter or get back to me after the talk. Thank you.
Good job, Philo.
Thanks, man.
Well done. So let me ask you, you are a Livewire OG, so how long have you been a Livewire practitioner? From the very beginning?
Not from the very beginning. I think I started with version 2, so not the earliest version, but
okay.
It was, yeah, quite a long time before it went mainstream.
And am I understanding that your Shopify plugins are also Livewire to some extent?
Yeah.
So you're writing Shopify plugins, selling them in the marketplace, written in Livewire?
Yeah. And they even like some of these, so even in the Shopify stores, on the front-end side, it was Livewire v2 for some apps. Livewire is basically running on a Shopify store, which is running on, Ruby, I think. So it's pretty cool to just embed Livewire components within a Shopify store. So it's pretty neat.
That is incredible. If you want to talk to him about Shopify and Livewire, please find him after. Everyone, give it up for Philo Hermans.
Thank you.